Hello friends, welcome to follow up. Let's have a look at problem 2706 by two chocolates. In this video, we are going to provide two solutions, and one is based on salt and the other is based on finding the two lowest prices. So in this problem, we are given a price list which represents prices of various chocolates. So we want to buy exactly two chocolates such that we still have some non-negative leftover money. So we would like to minimize the sum of the prices of the two chocolates. In other words, we want to still have as much money as possible after the purchase. So here the return is that. So we want to return the amount of money we will have left over after buying the two chocolates. And if there's no way for us to buy two chocolates without any in debt, so we are going to return the original money. In other words, we do not buy anything. So here are two examples. In the first example, so we can buy 1 and 2, so we get left 0 money. And in the second one, so the smallest price is 2, and the next smallest is 3. So if we make the purchase, so we are going to spend let's say dollars. It's larger than 3, so we just return the original money amount, that is 3. So that's the main problem statement. So let's also look at the constraints. First, the length of the list prices is bounded below by 2 and bounded above by 50. So this 50 is actually a not very large number for this problem. Secondly, each price is in the bound 1 and 100, and the money is also in the bound 1 and 100. So due to the constraints or assumptions, so this problem is a very small set problem. So we can do brute force or we can make some improvement. So here in this video, we are going to do two things. So here, first method is going to be based on salt. So this way, I would say it's very verbose or brute force. And the second way, so we're going to try to use an ON solution, linear solution. So we're going to find the two minimum, two least expensive, let's say, chocolates. This is our big picture. So the first solution, basically, it involves salt. It's going to be ON logarithm n, where n is the length of the prices list, and the second one will be ON linear time. So let's first look at the first solution. So here we can make a in-place salt. So this way, so the first two correspond to the least expensive ones. So we can see we can get this two. Let's call it 2 by. So this is sum of prices, the first two chocolates. And then basically we just need to check if this 2 by is larger than money. So we make no purchase, we return money. Otherwise we return the difference. So we are going to return money minus 2 by. If 2 by is no larger than money, right? Else, so we're going to return the original money. So this is the one solution. But this solution, I feel that it's not good enough in the sense that so we just do using salt without make further improvements. Let's first test it. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So this is the one solution. So now let's look at the other method. So I'm going to mark this one as V1. So notice that in this problem, so we are only focusing on the two least expensive ones. So we can actually find them by using a for loop or just a linear scheme. So I'm going to call it M1, M2. So this is the least expensive one. So I'm going to set them to be 100 at the very beginning. is due to the assumption that the price is bounded above by 100. So now I'm going to iterate over the prices. So I don't need to track the index, so I just use y. So for y in this one, and then we're going to do comparison. If y is less than m2, so we found a smaller one, then we're going to reset. So m1, m2 to be m1y. So here I didn't change y, but I write this format. It's just for explanation purpose. So actually, if we just write, we can just set m2 equals y, right? So otherwise, let's see. So we just do another check. So if y is also less than m1, right? It's very small. And then in this case, I'm going to do this, m1 and m2. So it's going to be this and m1, right? So this way, after we finish the iteration, so m1 and m2 will be the two least expensive ones. This is what we hope. Yeah. So we are going to return money minus m1 minus m2 if m1 plus m2 or this amount, right, is non-negative, right? So let's see. Let's just directly m1 plus m2 is less than or equal to money, the same thing. And otherwise, so we're going to return the original amount of money. So this second method, so basically just need a for loop or linear scan. It's an ON solution. Let's first do a check. Yeah, it passes one test case. Now let's look at the generic test case. Yeah, it passes all the cases. So that's about it for this specific problem. So here, due to the problem size, basically 50, it's okay to use the first method. But if we make a step further, so we can use this method. So this method is still basically we can carry out this. And basically, we just need to retrieve two of these least expensive ones, right? But you know, if the expensive ones we want, the least expensive ones we are going to retrieve is very large. So actually, for example, a general key. So we can use heap, right? That's also another comment we want to make. So with that said, that's about it for this video. Thank you.